Hi, ladies and gentlemen. This is Mr. Green. I'm sending you this Class Connect because I have to be in Dallas this week for a teacher development situation, and so I am not going to be able to be present at Class Connect today on Thursday. So I'm sending you this as a recording so that you can get everything you need. So, what are we looking at? You should have finished everything in Unit 1, have worked on the Unit 1, Part 1, and Part 2, and have them turned in. And we are working this week on Unit 2. Don't forget, make corrections, due dates, those things, type of things. What are we looking at? So, in the first couple of lessons there, you were talking about what surface area and volume were. If you are wrapping a gift for a friend, the box is the shape of a right rectangular prism whose dimensions are 1411 by 7, and you have 625 square inches of wrapping paper, will this be enough to wrap the gift? Well, let's remember what our formula is for surface area of a prism. For the surface area of a prism, first thing we do is we find the perimeter of the base times the height, and we add to that 2 times the area of the base. That's the surface area that we're looking at. So if we're looking at 11 by 14 by 7, let's say the 11 by 14 is the base. Then we're talking about 154 square inches on the base, and there are 2 of those. And our perimeter is going to be 50 inches, and our height is 7. So we just add these up. 7 times 5 is 350 plus 308 is equal to 658 inches squared. Now we only have 625 inches of wrapping paper. Are we going to have enough? Absolutely not. We do not have enough wrapping paper. It's one of the ways that you can use that information. So a rectangle has a perimeter of 50 meters and an area of 150 meters. Okay, this is a rectangle, has a perimeter of 50 meters. So we've got the length and the width of a rectangle. Okay, and it has a perimeter of 50 meters. So 2 times my length plus 2 times my width is equal to 50 meters. And an area of 150 meters. That means length times width equals 150 square meters. Now it says if you tripled only the width, what is the area of the scaled up rectangle? Remember, what are we doing there? We're multiplying the width times 3. So we'd multiply this by 3. It'd be 150 times 3, or 450 meters squared. That would be the answer to A. Because see, we tripled the width. That meant you tripled the area. Now, if you tripled both the length and the width, they're asking what is the perimeter of the area in the scaled up triangle. So remember, we're just going to be multiplying on that first, the perimeter equation there. So what are we doing? I get my pen to work here. B. We're going to take 3 times 2 lengths plus 3 times 2 widths is going to be equal to, you know what? I can factor that 3 out, and it's actually the same formula. It's 3 times 50, or 150 meters. That's the way you can use that information that was in that first couple of units. Okay? It's trying to show you some scaling factors and how scaling factors work in relationship to the length and the width and to the area of different objects. Okay? Okay. So let's look in the lessons 3 and 4. We start covering the surface area of prisms. Okay, we've already covered a little bit what is the formula for the surface area of a prism. Well, what do? We take 2 times the base, area of the base, plus the lateral surface area, which is the perimeter times the height. That's our formula for surface area of a prism. So I'm going to go through each one of these individually. We've got a 2 times 4, that's 8 meters squared. That's the area of the base, right? My perimeter is 2 plus 4 is 6 times 2 is 12. So P equals 12, B equals 8, and my H is equal to 5. All I got to do is stick those into everything. I get 24 plus 5 times 8 is 40. I get 64 centimeters squared. Okay, second one down here, it's the triangle. I'm going to need this side length here, and it's a 3 squared plus 4 squared, that's 9 plus 16, that's 25 squared, 25 is 5. So this length here is a 5. I'll need that to figure out the perimeter. My perimeter in this situation is 3 plus 4 is 7 plus 5 is 12. My area, the base area, is 3 times 4 is 12 divided by 2, which is 6. My height is 8. And so we can figure out the surface area. It'd be 16 plus 12 times 8 is 80, 96. And you add those together, you get 112 millimeters squared. Let's come over to this one. Well, perimeter of my base, 5 and 4 are 13 times 2 is 26. My base area is 5 times 4 is 20. My height is 9. I would just plug them into the formula here, and I would have 40 plus 26 times 9. Sorry, can't do that one in my head. 26 times 9, clear. 26 times 9 is equal to 234. 234, that's 274 kilometers squared. Okay? Now this one, I've got a 4 by 4. I need to find the size of this triangle over here. It is the square root of 2 times 4. Remember our isosceles right triangle? Our 45, 45, 90 right triangle? That's exactly what I did right there. I found that other dimension, that other side over here. Okay? So for my perimeter, I've got 8. See, your perimeter is equal to 8 plus 4 square roots of 2. For my area, I've got 4 times 4 is 16 divided by 2 is 8. And for my height, I've got 6 kilometers. And so plugging this into the formula, I'm going to take the perimeter times the height. I'm going to get my surface area equal to 48 plus 6 times 4 is 24 square roots of 2 plus 2 times the base is 16. Okay? 16 plus 48 is 58, 64. So I want to have 64 plus 24 square roots of 2. And that would be my surface area. Okay? Let's look at volume for a second or two. If we were trying to find the volume of this one, it's a trapezoid. So my formula for trapezoid area is 1/2 B1 plus B2. Okay? That's the area of the base times height. Okay? So let's look at this. What do we got? We've got an 8 and a 2 and a 4. So 8 and 2 are 6. Half of 6 is 3. 3 times 4 is 12. So So this is going to be a 12. Okay, that's my base. My height of the prism is 5, and so my total volume is 60. 5 times 12, 60. Cool. Let's look at this one down here. We've got a 5 by 7, so my base is going to be a 35. And to find the volume, I'm going to take 35 times the 8 height. Can't do that one in my head. 35 times 8 is equal to 280 centimeters cubed. Okay, got a triangle down here. It's an 8 by 9. Is that 6? 6 by 9. So my base is equal to 6 times 9 divided by 2, 27. And we're going to take that 27 times 8, which is the height. Can't do that one in my head. 7 times 8. 216 meters cubed. Cool. So we just now found the surface area and volumes of spheres. And you're seeing how I'm working these problems. Okay? Now this one is a question about Cavalari's principle. So they're asking, use Cavalari's principle to determine which prisms have the same volume. Well, let's see here. Area of this cross section is 3 by 3. That would be a 9 centimeters. And the area of this cross section is a 4 by 2. That'd be 8 centimeters. Those are not the same numbers, so these two would not be the same volume at all. But over here we've got a 12 by 7. That's a 94, 70, 84 millimeters squared. And this one is a 12 by 14. That's a 12 by 7, really, because it's 12 times 14 divided by 2, which is an 84 meters squared. Same dimensions, right? So over here we've got an 8 millimeter high. Over here we got 8 millimeter high. These two would be the same volume. Good job. That's easy enough to do. This one, we're looking at pyramids, and they want us to identify the height, the slant height, and the side base. So I'm just going to write A, B, and C on each one of these. Okay, so the height. Height starts at the top of the pyramid, the vertex, goes down to the base and makes a right angle. So in this case, it would be letter D. B, the slant height goes along the edge. You slide down the edge. A. Side length. Side length in this situation is you go to a side of the base and you're talking about C. Looking at number 2 here. Height. Start at the vertex, go down to the base. That'd be letter N. Slant height. You start at the vertex and slide down the side. That's going to be letter J. Okay? N, J. So the other one is side length of a base. So here's the base down here. M is the one that's the side length. Let's go here to number 2. So we're looking for the height. Vertex down would be a Z. B, we're looking for the slant height. Down one of the sides, it'd be the Y. C, we're looking for the side length of a base. It'd be this one right here, X. Easy enough to identify those. You ought to practice with it a little bit. Make certain you can identify each one of them. if we're finding the surface area of a regular pyramid. Surface area of a regular pyramid. So let's remember what our formula is for surface area of a regular pyramid. It's going to be 1/2 the perimeter of the base times the slant height plus the area of one base. So let's look at what we've got here. We've got an 8mm side. 4 times around, 8 times 4 is 32. Half of that is 16. 16 times my slant height, that's going to be 16 times 10.77 plus base 8 times 8, 64. So got to bring up my calculator because I don't know my 10.77s very well. Times 16 is 172.32 plus 64 is going to give me 236.32 meters squared. See how easy it is to do? It's not like it's a difficult process, right? So now we're looking at the volume. And what is the volume? It's 1/3 area of the base times the height. So in this situation, our base is 14, and they're telling me it's a square pyramid, so that's a square, even though it doesn't look like it on my diagram there. So I'm going to have 1/3 14 squared times 20. Well, can't do that in my head. So I'm going to say 14 squared times 20 divided by 3. And we wind up with 1306 2/3 centimeters cubed. And that would be my volume. 1306 2/3, 0.66667, that's 2/3. 1306 2/3 centimeters cubed. That easy to do. Okay? So, I know that you're watching this recording, and what I want you to do is I want everyone to send me a K-mail, and my secret word is candle. Tell me that you are in geometry and that you watched the Class Connect for this week, and just send me the secret word as candle. Okay? These are the things that we have been covering. We've been looking at representing pictorially, graphically, verbally, or symbolically in order to solve problems. And we've used numeric and geometric patterns to develop algebraic expressions representing geometric properties, and used 1 and 2 dimensional coordinate systems to represent points, lines, rays, and segments, and analyzing characteristics of polyhedra and other 3-dimensional figures and their component parts based on the expression of on concrete models. These are the topics that we have been covering. Okay? Hopefully, if you have any questions for me, you're coming to class to tutoring on Tuesday, Wednesday, or Thursday. Okay? I'm looking forward to seeing you in the next Class Connect. Sorry I couldn't be here with you this time. And we'll talk next time.